Integration is an operation that is the opposite of differentiation. In differentiation, we find derivatives, while in integration, we find integrals. Another name for integral is antiderivative, and this is why the process of integration is also called the anti-differentiation process. In differentiation, we are given a function and we are asked to find a derivative. For example, if the function is f of x equal to x to the power of 5, then we say that f prime of x is equal to 5x to the fourth. In differentiation, we are given f prime, so let's say f prime of x is equal to 5x to the fourth, and we will be asked to find the function, and in this case, naturally, it's x to the power of 5. There is an alternative notation to this. Instead of saying f of x, if f of x is equal to x to the 5, then f prime of x is equal to 5x to the fourth. We could just say the derivative with respect to x of x to the power of 5 is equal to 5x to the power of 4. So this notation combines these two equations into just one equation. The corresponding alternative notation in the integration process is this: the integral of 5x to the power of 4 with respect to x is equal to x to the power of 5. Now remember that the symbol dx here is just read as with respect to x being the variable differentiation here. And here it's also read as with respect to x because the variable of integration is x. So again, this notation here is read as the derivative with respect to x of x to the power of 5 is equal to 5x to the fourth. Well, here we say that the integral with respect to x of 5x to the fourth is equal to x to the power of 5. When we studied differentiation, the first rule that we learned is called the power rule, which goes: the derivative with respect to x of x to the power of n is equal to nx to the power of n minus 1. The opposite process will then be the integral with respect to x of x to the power of n, or x to the power of n with respect to x. And to get the answer, we do the opposite process. So instead of n minus 1, the opposite process will be n plus 1, and instead of multiplying it by n here, it will be dividing by n when we're doing the opposite. So it will go, the integral of x to the power of n with respect to x will then be x to the power of n plus 1 divided by n plus 1. But there is a little catch here. If we take our example from the previous, just a while ago, if f of x is equal to x to the power of 5, then f prime of x, the derivative, will be 5x to the power of 4. But notice that when f of x is equal to x to the power of 5, if you add any constant to it, let's say 7, the derivative will still be 5x to the power of 4 because the derivative of a constant is 0. So when we are given that f prime of x, is equal to, say, ax to the power of n, it is possible that the function f of x is just x to the power of n. It's also possible that it's x to the power of n plus some constant. And finding the value of that constant is not possible if we are given only this. We need more information to find the value of that constant than just being given the derivative. And this is why when we are integrating, we always add a plus c here for that constant which we do not know, and to determine the value of that constant, we need more information. Let's take some examples. So to find the derivative with respect to x of x squared using this formula, it will then be x to the power of 2 plus 1 over 2 plus 1 plus c, which is just x cubed over 3 plus c, which you could write as 1/3 x cubed plus c. Now, to check if our answer is correct, when we differentiate, when we find the derivative of 1/3 x cubed, we should get x squared. So let's do it. So d dx of 1/3 x cubed is equal to, so that constant here, just put it as 1/3, and then the derivative of x cubed is 3x squared. And this cancels out, and so yes, we get x squared. So let's take another example. Let's say the integral of x to the power of 7 with respect to x will be x to the 8 over 8 plus c, or you can write it as 1/8 x to the 8th plus c. Rule number 2. In differentiation, suppose we have the function x to the n and we multiply it by a constant k and we get the derivative. It will just be equal to, the constant k will not change, so it is equal to k times the derivative of the function x to the power of n, which is just then k times n to the x times nx to the n minus 1. It is similar with integration. If we have x to the power of n, we multiply it by a constant k, and then we get the derivative. It will just be k times the integral. We get the integral. It will just be k times the integral of x to the power of n with respect to x. So that will be k times x to the power of n plus 1 over n plus 1 plus c. So if we get the integral of 5x to the 4th with respect to x, for example, it will be 5 times the integral of x to the 4th dx, which would then be 5 times x to the power of 5 over 5 plus c. This cancels out, so the answer will just be x to the power of 5 plus c. Rule number 3. In differentiation, when we get the derivative of a constant, the answer is 0. Let's see how it goes with integration, and we will use the first two rules to do this. First off, suppose I put a variable x beside k. The exponent of x should be 0. And if we use rule number 2, we will have k times the integral of x to the power of 0 with respect to x. And using rule number 1, we will have this, which is just kx plus c. So the integral of a constant is just the constant times x, if we are integrating it with respect to x. So the integral of 5 dx, for example, will just be 5x plus c. The integral of pi dx will just be pi x plus c. Rule number 4, the sum or difference rule. If you have two or more functions, or if you are getting the derivative of the sum or difference of two or more functions, which could be really taken to mean that if you have a function with more than one terms, then the derivative would be just get the derivatives of the individual terms, or d dx of u plus d dx of plus or minus. And the same is true for integration. So the integral of the sum or difference of two or more terms will just be the integral of the individual terms. The sum or difference of the integral of the individual terms. So u dx, the integral of v dx plus or minus, so on and so forth, then plus the constant. Let's take some examples. So here, we just get the derivatives, the integral of the individual terms. So the first one would be 6 x to the 6th over 6 minus 4. This is x to the power of 1, so it becomes x to the power of 2 over 2, plus this is sort of the integral of a constant will just be that constant times x. And then all of these will have our plus c. So this is simplified as x6 minus 2x squared plus 3x plus c. Another example. For this, let's rewrite this in exponent format. So let's write this as the integral of x to the negative 3 minus x to the 1/2 dx. Now let's apply the power rule. It will be x to the negative 3 plus 1, negative 3 plus 1, minus x to the 1/2 plus 1 over 1/2 plus 1, and everything plus the constant. So we could write this first term as negative 1/2. Okay, let's write this first as x to the negative 2 over negative 2 minus x to the 3 over 2 over 3 over 2 plus c. So x to the power of negative 2 is just 1 over x squared. So we could write this first term as, instead of divided by negative 2, it's like 1 over negative 2 or negative 1/2. Okay, hold on, let me do it here. Okay, let's back up. Let's simplify x to the negative 2 over negative 2 here. We could write this as 1 over negative 2 times, this is 1 here, times x to the negative 2, or negative 1/2 times 1 over x squared. So that is really, this first term here could be written as negative 1/2, or negative 1 over 2x squared. And then this, the second term here, x to the 3 over 2 over 3 over 2, we could take this as 1 over 3 over 2. So 1 over 3 over 2 just means the reciprocal, so that's 2 over 3. And then x to the power of 3 over 2 is actually the square root of x cubed. So we could write this as minus 2/3. You can even keep it as x to the power of 3 over 2, and then plus c, or negative 1 over 2x squared minus 2/3 square root of x cubed plus c. For rule number 5, let's look at the chain rule shortcut for powers. In differentiation, we said that if f of x is any function raised to a power of n, if we get the derivative of that, then it would just be equal to n times f of x to the power of n minus 1, and then we multiply. Okay, I'm going to write this down. I'm going to rewrite the answer down here. So that's n times f of x to the power of n minus 1, kind of like the power rule, but then you multiply it by f prime of x. This has an equivalent with integration, but it doesn't work for any function f of x. It only works when f of x is of the form ax plus b. In other words, we could only do sort of the reverse process of this is if f of x is in the form ax plus b. So the integral of ax plus b to the power of n. This cannot be any function. It can only be ax plus b for this process for this method to work. So it will be the equivalent of this part will be your f of x here is ax plus b. And then instead of n minus 1, we do n plus 1. And instead of times n, we do divided by n plus 1. And instead of times f prime of x, because the derivative of ax plus b is, the derivative of ax plus b is a, we divide this by a. Now, dividing by a is like multiplying by 1 over a. So it's easier to write this as times 1 over a. All right, let's take some examples. But we forgot our dx here. And we also need a plus c here. And so for this, we do 2x plus 3 to the power of 5 plus 1 is 6, divided by 6, and then times 1/2. Because the derivative of 2x plus 3 is 2, so we divide this divide this expression by 1/2 by 2, or times 1/2, and then we will have our plus c here. Let's just simplify it. We could write this as, this is actually 1 over 12, so 1 over 12, 2x plus 3 power of 6 plus c. For this, let's first write this as the integral of, in exponent form, 1 minus 2x to the power of 1/2 dx. So that will be 1 minus 2x to the power of 1/2 plus 1 over 1/2 plus 1 times 1 over, derivative of 1 minus 2x is negative 2, then plus c. So if we simplify this, we get 1 minus 2x power of 3 over 2 over 3 over 2 times negative 1/2 plus c. Okay, let's simplify some more. So when we have 1 over 3 over 2, we are just getting the reciprocal. So this whole first part here we could write as 2/3 1 minus 2x power of 3 over 2, and then times negative 1/2 plus c. So we can now multiply this and this. So we get negative 1/3 1 minus 2x power of 3 over 2 plus c.